Hello everyone, my name is Irene. Welcome to ASUS EPYC 9004 product launch webinar. Please be aware that this webinar will be recorded, and you can scan the QR code to download the deck at the end of this presentation. Then Alexey, the AMD server marketing from Data Center Business Unit, will give you more insight into EPYC 9004 CPU design and solutions. Then Victoria will talk about ASUS EPYC 9004 server solutions. Then we will conclude with a question and answer section. I hope you'll enjoy this webinar with us. Now let's welcome Alexey.
And hello everyone. My name is Alexey Nechuyatov. I represent Data Center Business Unit at AMD in the EMEA region, and today I'm glad to present to you our newest 4th generation AMD EPYC processor family. We've announced it just recently on November 10th. Since its introduction, the AMD EPYC processor family has been accelerating workload performance at a rate much higher than the competition, and we are delivering on time. The 4th generation EPYC, codenamed Genoa, in fact has exceeded our performance targets. It's bringing 6.5 times increase in application throughput in just 5 years. It's a 45% compound annual growth rate, which is amazing for this industry. This chart represents top of the stack comparison in spec integer benchmark, which is industry standard for corporate application performance measurements. And so customers take notice. We started out with cloud providers. Today, this was back in 2017, 2018 when large hyperscalers started buying our products. Today, we have 10 out of 10 largest hyperscalers buying predominantly 64-core AMD EPYC processors, and also there are a lot of regional hosting companies offering us for dedicated hosting and VPS as well as shared web hosting. In the HPC, we've seen quite a bit of attraction ever since we launched our 2nd generation EPYC ROM processors in 2019. And if we look at the top 500 announcements, in just 12 months, we went from 24 to I think 74 systems, and we also shipped our technology, both CPUs and GPUs, to the largest exascale system called Frontier last year. In terms of the enterprise segment, this is a segment which takes more time before moving to AMD processor technology, but we also see great momentum there. There are customers representing very different verticals, and I'd like to quickly cover why there is that trend, why AMD EPYC is popular and gaining momentum. Well, first off, it's really performance, and extra performance again. Customers converted into lower development time, into making decisions faster, into making greater server consolidation, into maximizing their software license investments. Secondly, it's performance per watt. All these extra cores actually have better performance per watt. There is high performance. You have some high frequency SKUs as well if you want the highest performance per thread. But overall, basically, this performance per watt allows you to reduce power consumption, reduce DC footprint, make your rack utilization higher, increase the performance per kilowatt, increase the number of VMs, users hosted per server, and achieve your sustainability goals, which is quite important in Europe, for example. So, and we see in Europe people moving to single socket systems, which is another hidden gem from AMD, because these single socket systems are amazing for non-CPU bound codes. And there is an amazing amount of I/O to equip all these cores with throughput. And so as a result, you see customers moving from dual to single socket to lower platform costs, to utilize resources better, to increase their power efficiency and reach their sustainability goals again. And then finally, the most important thing is that we execute. time and time again. We trust, we gain trust because we deliver differentiated products on time. And so if you look at our roadmap here, you can see 4 generations of AMD EPYC processors. Genoa is just our first iteration in the 4th generation family, which is 5nm chiplets. There'll be Bergamo sitting on top of the Genoa stack. So Genoa is 16 to 96 cores. Bergamo will offer up to 128 cores. So it's adding to the top. It's fitting the same SP5 socket. Genoa X again going into the same socket, but having extra cache, it will work in a great way for technical computing, maybe with some databases. And then Siena is also another product, another platform, which is catering to telco, to edge deployments, and to software-defined storage applications. Turin is our next generation, will fit in the socket infrastructure developed for the 4th generation processors. What's important is that Rome, Milan, Milan X, so 2nd and 3rd generation processors don't go anywhere. They are produced by AMD and they offer the best performance per system dollars. So these systems represent great value and they offer competitive performance. We're gonna sell concurrently both our 2nd and 3rd generation and our 4th generation processors. They have different meaning. So in terms of the 4th generation processor innovations, I would call out several things. We've managed to pack 14% higher IPC instruction per cycle. We grew our base and maximum frequencies. We've increased our Infinity Fabric throughput, so it's not 16 but 32 gigabit per second. And then we intersected all this goodness with faster memory throughput, so we have 2.25 times better memory throughput compared to previous generation using DDR5 4800. There are now 12, not 8 memory channels, so lots of throughput on the memory side to feed all these extra cores if you need. And then there is also double the speed in terms of the I/O, because it's not Gen 4, it's Gen 5, so double the throughput on the I/O bus. We also added one new exciting feature, which is Compute Express Link support, allowing us to add memory expanders expected next year. So you'll be able to add even more memory. It will sit on a PCI Express bus. It's a new type of memory, but we do support it. And there is also quite a bit of going in the Infinity Guard in our security subsystem. Essentially, we doubled the number of keys we can issue to VMs, container pods, to protect hypervisor, all system memory, and we also doubled the encryption key strength, so it's 256 bits strong now. Well, this is quite an eye chart. Let me just call out several most important things. So we continue sticking to chiplets. There are up to 12 chiplets now if you choose 96 core part. The entire chipset, as before, is under the heat spreader, all integrated, no external logic on motherboard. In terms of the processor instructions, we've added AVX512 to accelerate things like machine learning and some HPC applications. We approach it using double pumped way, so we split into 2 boards instead of 1, executing on 2 cycles. As a result, our frequencies don't go down. And we manage heat very well, so there is no heat on frequencies, and we keep the overall processor performance up when we execute such instructions. The other thing that I would call out is 400 watt TDP, configurable TDP for the top of the stack parts. Let that not scare you. The overall performance per watt is up to 50% better over the 3rd generation Milan processors. We manage dynamic average power much better, but we wanted to upgrade this peak power in order to make sure that at peak loads CPUs can still deliver. There are still 200 watt CPUs in the stack, so there is definitely quite a bit of a choice for you to make. In terms of the memory subsystem, there are 12 memory channels. Single and dual channel designs are available, but there is a physical limitation for dual socket motherboards. So you mostly will see 12 DIMMs per socket tops with the dual socket designs. You don't need to put all 12 memory channels in. They're expensive. It's DDR5. You can do away with a lesser amount. And Intel Living is available for 2, 4, 6, 8, etc. Memory channels as well. If you have fewer than 96 cores, well, see if it makes sense for you to invest into a memory subsystem, and if your code require memory bandwidth as much as possible. The other thing I would like to call out is that we still have the same up to 128 PCI Express lanes per single socket and up to 160 lanes per dual socket. And I believe that the ESC 8000 AE11, which is 300 watt GPU box from ASUS, is actually using some of the socket-to-socket links and repurpose them for the I/O, for direct connection of GPUs for efficiency, talking in an efficient way to CPUs. Quite an amazing box. I recommend to read the review on Serve the Home, I think from last year. Really congrats on that system design, really impressive, ASUS. What else? I've spoken about the security features. One last thing. There are now 30, not 16, but 32 bonus lanes for SATA device connection. They don't use PCI Express lanes. And there are some extra bonus lanes, Gen 3 or Gen 4, on top of the 128 or 160 lanes that I've spoken about. So this is a throughput monster, a compute monster. You have so much memory. It's really amazing what we've done with this generation. The stack follows the same logic. No matter which CPU you buy, you always have one standard set of technologies that you acquire from AMD. We don't move people to buy dual socket or more expensive CPUs. Our single socket processors with letter P at the end have the same set of features. It's just that they are locked to work in a single mode only. But their price is actually aggressive because we want people to move from the same core count dual socket competitive setups. And so look at these P models. Now, the models that are highlighted in blue are our highest performance per thread. So there is letter F frequency at the end. So these models would provide you the best performance per core. And then overall, we have 3 categories of CPUs. So there is like mid of the market, anywhere from 16 to 32 cores. This is one group. There's great performance per dollar with this. Then there is high density group, so 48 to 96 cores. And then there are specialty CPUs. So say high frequency CPUs is falling into that category. When we launch Genoa X with extra cache, it will also fall into that specialty category. So performance-wise, what we're getting is really a very balanced performance across all tiers, across all markets. If you look at the stack integer throughput, I'd say this is a good metric, good t-shirt sizing for cloud instances. We compare top of the stack product, 64 core to 96 core, 2 generations, and you see up to 107% better performance. In fact, this score, stack integer score, I believe was submitted by ASUS Tech. So again, congrats ASUS on the fastest performance on the market. HPC, so this is really, HPC applications are more floating point dependent, and so that's why we use stack integer for floating point, and we look at the throughput, at the multi-threaded performance. Again, whopping 123% better result. And then in the enterprise segment, with Spec Java JBB Max, I don't remember exactly the benchmark, but this is really about max throughput, how many operations, Java operations you can do per second. And given that there are a lot of mid and front-end applications using server-side Java, this is a good metric for anything enterprise. And so we are seeing up to 93% better performance when we compare 64-core Milan to 96-core Genoa processor. And obviously, one might ask, so what happens in the more democratic niche where there are fewer cores? Well, if we compare 16, 24, and 32 core CPUs, we see up to 26% better mid-stack performance. So again, this generation is quite powerful. 26% is no small feat. And then, as I said before, we are seeing overall up to 50% better performance per watt with this generation. How do we translate that into something which customers can really appreciate? Well, this is in part all about economy, about the economic impact. And so we don't have enough time at this during this webinar to go into many TCO scenarios. We have a tool which is called virtualized or bare metal TCO comparison tool. They're available on AMD.com if you Google AMD, if you Google for AMD EPYC tools. And we have an NDA version for professionals, which really allows you to configure different scenarios and see what your TCO is going to be like in 3-4 years using different regional costs. And so here is a scenario where we have a certain application performance target, 10,000 spec score, and we migrate from dual socket top of the stack 8380 Xeon Platinum processors, so 80 cores per server, to 16 cores single socket 64 cores, so 80 to 64 cores, the newest generation. So we compare what's currently available from the from our competitor, top of the stack, and we come up with this. It's 53% fewer processors to power and to buy. And probably these are not, these could be shallow depth systems as a result, so you save space as well. You use less power, 33%. You lower as a result up to 29% your TCO. This obviously results in your carbon sequestration, which amounts to 38 acres of US forest annually. So, and there are different scenarios that you can play. In general, wrapping up this session, let me say this: Genoa is a logical continuation of the journey that we've started out back in 2017. We again delivered on promise. We basically doubled the performance. If we compare top of the stack parts, there is significant gain in the mid to low end in moderate core count segment. It became even more energy efficient. We continue to drive our single socket advantage. We now look into solutions, so we formulate solutions with our ISV partners and hardware providers such as ASUS. So it's not only about fits and speeds, but you get validated size solutions. There are a lot of hyper converged infrastructure nodes available today from our partners, for example, to automate and scale your data centers. There is robust security and confidential computing. In fact, we are the only x86 supplier which is able to encrypt VMs and make it a bit more secure for your multi-tenant and off-prem environment and deployments. And yeah, definitely, we are working on the time to value. From day one, when you buy your service solution from ASUS, you can see how it adds to your competitiveness, to your time to decision, and you spend less on running your server infrastructure. So with that, let me thank you for the opportunity to present Genoa today, and it's over to Victoria. Thank you.
Hi everyone, my name is Victoria. I'm the product manager for the ASUS server team. Today, we'd like to share our latest AMD EPYC 9004 server solutions with you, including the performance records, product offerings, and the special and unique features of this new generation. ASUS have been in the server industry over 25 years, and our performance leadership is proven by achieving over 1,000 benchmark world records on Spec CPU 2017 and by being recognized by Spec Power as the provider of the world's most power-efficient servers. For AMD EPYC processors, we have received over 36 #1 world records on 2P and 1P benchmarks with RS 720A and RS 520A series. Our EPYC GPU servers also stand out in performance in version 2.0 of the leading AI benchmarks, MLPerf training and MLPerf inference. We have to ensure your data center delivers time to market with excellent computing speed. ASUS servers feature comprehensive product offerings for GPU servers and general-purpose servers. When a customer needs one socket platform, we have the RS520A or RS500A series. If they need powerful performance and two sockets, we can provide the RS720A or RS700A series. For compute density, there is the two sockets RS720QA-E12 model. For mainstream GPU server, there are two kinds of system you could consider. The ESC4000A supports 4 graphics cards, and the ESC8000A supports 8. ASUS server design DNA operates in 3 dimensions: versatility, flexibility, and scalability. We offer various configurations, cooling solutions, and different upgrade kits. Depends on your anticipated workflow. Our new EPYC 9004 servers deliver best-in-class capabilities with speeds up to 75% faster than previous generations, up to 96 cores, and next generation 5nm technology. They also support highly performant DDR5 memory modules with 12 memory channel with dual channel capability and 128 PCIe Gen 5 lanes. All ASUS EPYC servers are certified for the latest AMD MI210 accelerator and Xilinx FPGA cards. And our system maintain NVIDIA certification and are qualified for various NVIDIA graphics cards. We also have independent airflow tunnels to support 2 processors, consuming up to 400 watts each, and 8 graphics cards, consuming up to 350 watts each. Here are some new design features for this new generation. We have front bezel with a lot to avoid accidental usage. Consider better open ratio on hard tray, extending storage lifecycle, and better user experience. New hard tray design can improve more than 13% on open ratio and thermal air increasing 9 CFM. For ASUS Thermal Radar 2.0, sensors are embedded on the front bezel, CPU, sockets, NVMe SSD slots, and memory slots. Fans are also grouped for dynamic fan curve adjustment in different fan zones to achieve more precise thermal monitoring. More precise thermal information can reduce power consumption and improve TCO. For ASUS Power Balancer, dynamic monitoring and feedback CPU loading to have more accurate management on the system. Dynamically and automatically adjust CPU frequency based on current utilization to reduce power consumption and optimize performance per watt for a better power efficiency system. Liquid cooling is no doubt the trend for future data centers. But before choosing a cooling solution for your data center, you may want to know these questions. How many kilowatts of heat do you expect to remove from a rack and an individual rack? How much power usage effectiveness do you expect to achieve? Liquid cooling can reduce fan energy consumption by 4 to 30%, which can improve PUE and reduce your overall electric bills. ASUS introduced two types of liquid cooling solutions. One is direct-to-chip liquid cooling that places a cold plate directly on top of components such as CPUs and GPUs. It continually funnels the heat that generates through the liquid coolant networks to a cooling distribution unit located in the rack. Another is immersion cooling solutions that place an entire server in a thermally conductive dielectric fluid for maximum heat dissipation. The building blocks of direct-to-chip liquid cooling solutions at the rack level include rack manifolds, CDUs, and cold plates. ASUS will provide servers ready for GPU and CPU liquid cooling in the first half of 2023. For immersion cooling solutions, ASUS will collaborate with strategy partners, including Summer and Gaoli. The tank hardware capacity of Summer ranges from 6U to 41U to support dissipation capacity from 5,000 watts to 100,000 watts. They use a hydrocarbon-based solution dubbed Smart Coolant. Alternatively, Gaoli provides a customized tank that they fill with a fluorocarbon-based coolant. Smaller tanks in the 4U or 6U range are typically used for edge applications, while the larger sizes are suited for data centers. Let's talk about computing performance. Historically, hardware rate has been limited by the data rate of available PCI lanes. Basic software rate only delivers 10% more performance for SSDs, while consuming almost all CPU computing power. In order to resolve the bottleneck, great technology has developed a disruptive software and hardware solutions to unlock performance SSD rate. ASUS servers have adopted this technology, and they can deliver up to 16 million 4K random read IOPS and a throughput of up to 110 gigabits per second. Hyper-coverage infrastructure is a critical application in the age of the hybrid cloud. ASUS EPYC servers can deliver in use cases such as remote offices, edge computing, data centers, and flexible workloads. Not to mention Azure Cloud. Combining Azure Stack HCI and Azure Cloud can deliver total solutions to realize new workflows. Based on different segments, with AMD's new generation of EPYC 9004 CPUs, our new servers offer high density with the 2U4 R720QA, high performance with the R720A and R700A, and a mix of both with the R520A and R500A. All of the new models can support highest processor CDP of 400 watts. And there are multi-configuration options for redundant power supplies. ASUS is not just a hardware vendor, but also a total solution provider. We are an expert for building supercomputers. Customers can work with ASUS to empower data center. For example, by combining AI, tech, and GPU servers, ASUS offers real-world solutions for real-time traffic monitoring and earthquake prediction. With ASUS expertise, we can build more HPC data centers with AMD platforms. These new GPU servers have two segments, the ESC4008, which can handle for 2-slot graphics cards, and the ESC 8000A, which can handle 8 2-slot cards. Both are powered by AMD EPYC 9004 processors, and they can support a CDP of up to 400 watts using the standard heatsinks. They also offer up to 5 PCIe slots to support network cards, graphic cards, or storage. That's all for my part. I hope this helps you to get a better understanding of ASUS EPYC 9004 server solutions. Thank you.
Next is the QA section. Please enter your questions in the chat box on the right side of the window. Our PM, R&Ds, and sales are all available and willing to answer your questions. The Q&A section will be lax for 10 minutes. I hope you enjoyed today's webinar. You can scan the QR code to download the deck of today's presentation. If you have any questions, please feel free to contact us. Wish you have a wonderful day. Thank you.